Okay, before we start on the paper that you guys have in front of you, I want to talk about just a couple of things to be sure you understand. Okay, so I just want to ask you, if in the past, okay, I've given you problems like x squared equals 16. And to solve the problem, we would take the square root of both sides, right? So we would know that x is 4. Okay, this is an exponential, right? It has an exponent. But in here, in a problem we've studied now, I'm going to change it and say 2 to the x equals 8. Notice the difference in where x is, correct? So if x is here, what you're trying to find is the exponent, okay? We know the answer is 3. You found the fact that it's 3, okay? But in order to get x down, okay, to solve it, if I wanted this to be an x equals, but I didn't know it was 3, let's say the problem is harder, then do you remember what we're supposed to do? We talked about it yesterday. We should do what to this? To bring the x down, we should... Okay, you can find the common base, yes, and that would solve it. What else could you do? What was the inverse of an exponential? What do we change exponential into? We had 2 columns yesterday, exponential column and a log column. We went back and forth, right? So if I want to make x so that the problem says x equals, okay, then what I will do is I would rewrite this. The base here becomes log base 2, right? And you can do circle math if you want. So log base 2 of 8 equals x. And now notice x is no longer an exponent, okay? And in a hard problem, right, like in a real world, real life situation, you would use your calculator and solve, okay? And it would give you 3. Now, but so that we completely understand the concept of why that works, that's why we're doing a lot of them by hand right now. And we will do more and more with the calculator. But if you don't understand what the calculator is doing, it doesn't do me any good. Do you see what I'm saying? So that's the reason. We know the answer is 3. I know to get from 2 to 8, I cube it. But if you have an exponent that's up high and you want to get an x equals, then that's how you take the log. Okay? And the other thing I want to talk about is if I gave you 3x equals 15, how would you solve for x? What would you do to get rid of the 3? You would divide. Because the inverse operation of multiplication is division. We just see it so often that we're just used to it, right? And we just automatically know. Well, it's no different than over here. If I have this and I can't find the answer, and we know it's 3, but if you don't know the answer automatically, we're not as good at saying, oh, not a big deal, just turn it into a log problem, right? Because we haven't studied it as much. But those are the same ideas. It's just that you've seen this so many times. To solve for x, we're just going to divide by 3 and be done. Okay? Over here, if you can't look at it, like in here we know the answer is 3, but if you can't look at it and know the answer is 3, then you turn it into a log. You undo it. Okay? Just like we undo multiplying by 3 by dividing by 3. Okay? So that's what we're going to kind of talk about. Maybe that explains it a little better so that you understand a little bit more. So if you take a look at your graph paper, this paper here, it tells us that here's an exponential function. It's going to give us this. And it tells us to find the inverse. Okay, guys, we already did inverse. When we studied linear equations, I made you graph the linear equation, find the inverse, and graph it again. We did it with straight lines. Do y'all remember what we did when we would find an inverse? You would graph the first equation. For example, I would say to you, okay, guys, graph for me x plus 3. And you would just graph me a line. Then I would tell you find its inverse and graph it again. Do you remember how we did that? Yeah, you flipped x and y and solved it again, right? You would change x and y, and then again you'd be like, okay, now I gotta solve it again. Move the 3 over, so y equals x minus 3. And you would graph it this way. And when you did graph it, what did it reflect over? When you find the inverse and graph it, it's a reflection of each other. Or is it a reflection over the x? Is it a reflection over the y? Do y'all remember what it, you may not, but what is it a reflection over? When I find an inverse, so when I graph something, and I find the inverse and graph it again, remember we called this f of x, and then we would call this f of negative 1 of x? when I graphed it, what did it reflect over when you find inverses? You're close. It's actually the y equals x line. It's a y equals x. If you flip x and y, then you're flipping it over the y equals x line. Okay? So that's how we've already done this with lines. Now we're going to do it instead of with lines or quadratics, we're going to do it with logarithms and exponential. Okay? And the point is to try to show you that the inverse of an exponential will turn into a log. And the inverse of a log will turn back into exponential. So right here, it says find the inverse. So here's my original function. This is your f of x. Okay, we talked about this before. How do you find the inverse? We flip x and y. So let's do that first. So step 1 then turns it into x equals 2 to the y power. Now we're gonna, we flipped x and y, but we can't graph that. In order to graph it, that needs to be a y equals, correct? So how do we find an exponent? How do we solve for y? How do we bring the y down? We log it, okay? So if you want to solve for y, if you want to find this, they're not always easy. You can't always find the exponent by looking at it. So if you want to bring the log down, if you want to solve for whatever the exponent is, you log it. So some of you, if you're going to do circle math, you can go this way, but the base of the log is the same as the base of the exponential. So you start with 2, you go through x, and then what's the answer? Y. Okay, so if I talk to you about that again, y equals 2 to the x power. Okay, we just found its what? What do we call it? What are we studying? We found its inverse, and its inverse became a log. When I flipped x and y and solved for y again, in order to bring y down, I had to log it. So to undo exponential, we log. Okay? It's just not something we've seen before much. Right now, it says here, graph both equations on the same grid. Okay, so for the first one, our formula is y equals 2 to the x power. Now, this is exponential. And we talked about this yesterday, and I know some of you listening in are in a different class, but we talked about yesterday about powers of 5. And what happened when we found all those powers of 5? It started out making small jumps, but then by the time I got to the 5 to the 8th power, how big were the jumps? Big. So if you don't know what an exponential graph looks like, it shoots up really fast, okay? And it looks a little bit like a parabola, okay, but not, because it's only like half of one, okay? So let's make a graph real quick. And this is x and this is y, and we're going to use -2, -1, 0, 1, 2, and 3. If I input those values in for my original graph, my exponential graph, so 2 to the -2 power is 1/4, 2 to the -1 power is 1/2, 2 to the 0 power is 1, 2 to the first power is 2, and then 4 and 8. Now, when we found the inverse, we flipped x and y and solved for y. And when we did that, okay, we came up with an inverse function that looked like this. That's not as pretty to find all the answers to, is it? We're not as comfortable with that. Okay, what then is another way, if I know those are inverses of each other, what's another way to get my new table? What can I do instead? Instead of doing all the math again, if it's an inverse function, what do we switch? The x's and the y's. Can't I just do that with the values? Yeah, switch to x and y's. Okay, so all the y's are now x's. And all the x's become y's. Okay, then you want to do graph the original function and graph its inverse. And you might want to graph them in different colors maybe a pencil and a pen or whatever, so you can kind of see them a little better. And I realize the numbers, guys, are little tiny, okay, but just do the best you can. Right, so graph each one. Okay, what do you notice about the output? All the Y's are up top in quadrants 1 and 2, aren't they? Are any of the Y values down low, down here?
No.
We have negative input, we have negative X's. But do we ever get any negative Y's? No. Because if you raise it to a negative, the fraction just gets smaller and smaller. So it's not gonna go down unless you shift the graph all around, okay? But this is a basic graph. So look what happens, look how fast it shoots up. You'll see it? Now in a different color, okay, hopefully if you have one or a pencil, graph the other function. I'm not sure you can look up here to see from how it's. Okay. Now, like I said before, guys, this would be labeled, you can label them, this would be labeled f of x, right, our original function. And the other graph would be labeled, when it comes down here, f of negative 1 of x, right, the inverse of x. We talked about that already. And when you have any inverse function, these just happen to be exponential and logarithmic. Okay, but if you have inverse linear, inverse anything, okay, it just means you're flipping x's and y's. And it will be reflective over this axis here, your xy axis. And that's how you'll know you did it right. And if you take a look at this really carefully, look, if you're on this bottom and you jump over the line, look, they're mirror images of each other. If you graphed it nice and neat, you just jump over and over. Close enough, right? Some of you are sketching, it depends on how well you sketched. Okay, so let's see what we noticed then. Okay, down here it says in x equals 2 to the y power, what's y called? We already know this. Y is the exponent, but what are you finding when you find an exponent? A what? A log, okay. And then this is the next thing we just proved, okay? A logarithmic function, the inverse of an exponential, okay, is a log. Okay, so if you had y to the 2x and you flipped x's and y and solved, you're gonna get y equals log of base 2 of x. We just proved that. And there it is graphically, there it is table, okay, and there it is mathematically, all 3 ways. So let's flip over and we're gonna do 2 more graphs. Now in this situation, guys, you would need a calculator on number 1 in order to build your table, okay, because the fraction's messy. And it says use the x values, negative 2 through 2, to graph the function and its inverse. Okay, describe the domain. Now, there's several ways to find an inverse. If it's exponential, you can turn it into log. But graphically, if you get your x and y column, what can I do to the x and y column? Just switch them. So let's build a column for the first function and switch the columns for the second and graph both. Okay? So let's do that. Make a table then for f of x, your original function. And it's said to use negative 2 through 2. And just because your input is negative in an exponential, it just means your answer gets smaller and smaller, right? Your output will be positive for this particular graph. Okay, so input these into the calculator. So if you input -2, you get 0.64. If you input -1, you get 0.8. And then 1.25, of course, and then 1.56. Now if you want the inverse, I'll use another color so I can figure out which goes with which, but if you want the inverse, it would look like this. And because it didn't actually ask me what the equation looked like, I'm not gonna make the equation. I'm just gonna flip the tables. All it asked me for was the graph. So flip the tables. So we put 0.64, 0.8, and so forth on this side. Okay, and then very carefully graph both. It's really hard to tell what this graph does. To me, it looks like a straight line, doesn't it? Okay, let's say I go all the way to 5. Do 1.25. If I put 5 in, I get 3.05. That might help you make the graph look a little better. Okay, and the graph actually is going to slowly go up. It's because the base is so little. Right, it's just barely over 1. Now go the other way. So you're going to label this f of x. Okay, when you graph this one, they look like you could just, you folded your paper, you can fold it onto each other. Right, if I folded this orange line over and fold on top of the purple. Right, because they should be reflective over this axis, over the y equals x axis. So if you're here, you could jump over the line and land here. Here would land you here, and so forth. And then you're going to label the other one f of -1 of x. Okay, so what you should have learned is that to get from exponential to logarithmic, okay, right, they're inverses of each other, right? In other words, their x's and y's flip. Or they reflect over the x equals y line if you graph them. Okay, let's do one more graph and then we'll move on. We graph the original.
So are we going to be able to use a calculator to find out what
The values? Yes. something like this. Now, especially on number one. On number two, you can kind of do those in your head.
What?
Is 1/2 to the -2. If you squared 1/2, you're gonna get 1/4. And then it put the 4 on top, it's negative. Y'all aren't liking that.
No.
Sorry. Okay, graph both. And when you do, your graph should look something like this. There's my table. And there's my graph.